So this is what's going to be on the final, right, Zoom?
Oh, what?
This material we're going to cover is just going to be the final, right?
Yeah, I'm just going to go through the two samples we posted online. Have you done that?
Oh, not yet.
Yeah, okay. We'll just go through that. Okay. So there are two samples and 3 questions in each sample. We'll just go through like one by one, like take some time trading it.
Teaching is not business.
How's the exam going to be?
Just like 4 questions.
4 questions?
Yeah.
Awesome.
This one's from like 94.
Mechanics hasn't changed since I.
Yeah.
Some of the stuff we're learning is the stuff they were learning in like 60s, 50s.
Okay. So.
I have no clue how to do this.
This one? This is like chapter 10 or 11.
Oh, yeah.
Yeah.
I
Can't see what does that say.
Okay. Maybe we should.
That's much better.
So, in this kind of question, he's asking for maximum deflection and maximum slope. So what I would do here is I would use singularity function.
Okay.
And keep integrating like we did before. Is using singularity function we can get a shear force and moment. But if you keep integrating, you can get a deflection and slope.
usually there's like, when I did the homework, usually you integrate twice, you integrate 4 times.
Yeah.
So for the
How
first
do you know if you integrate 2 times or 4 times?
Like if the first step you do is your right is okay. I'll just let's say. So the first step you do is you write out the omega x equation, which is this is based on the question over here. You need to write out the omega x equation from here,
Okay.
and if you integrate for one time, integrate this, you get shear force, and integrate you get moment, and integrate again you get dv dx, which is the slope.
Okay.
And
Wait, what's dv dx? That's the
Just the
slope?
slope.
Yeah, it's a slope.
Slope of deflection, right?
Yeah.
Oh, okay.
So, and you integrate one more time, and you get the deflection. So the question here is asking you for these two, slope and deflection.
Mm-hmm.
So if you have no question in writing out this, then this is easy to do. Like, if you want to try on, like, see if you can write out the omega x equation for this one. There is one pin here, and one torso here.
Wait, where's the other pin? Wait, is that pin up or down?
This pin is like this, a triangular point towards down, and this is a triangular point towards down.
Okay, so this one's so it's holding on here and then it's bending this way. Okay.
Yeah.
So it's like this. I think it's something like this now.
Yeah.
Yeah.
And then P.
You can just leave the P as P. Doesn't matter.
Yeah, my only question is, what are we going to call those?
Force at here.
Yeah, what are you going to call them? A and B or?
You can call it as whatever you want, but you have to calculate it in
Yeah.
terms of P.
In terms of P, yeah.
Yeah.
Slightest clue. So why don't you just go through this one, because I mean I haven't got the slightest clue right now.
Like. You have no idea how to
I
start?
I have no idea how to start right now.
Okay, so.
Can I just say, can you take a moment at the first pin?
Yeah, you can take a moment at
Because
first pin.
then I can find the second pin with respect to P, and then I can do the sum of forces, and then.
Yeah. Yeah.
Okay, so that's how I started.
And you know what they say?
Yeah, so I mean, well, so the right way to start is just like start with being the moments around that first pin one, and then just doing your calculations algebraically.
Yeah, you can do it this way. It's like,
Oh, what's another way to do it?
like, another way of doing it is, like, if I have this force, I call it F8, and this is FB, and this is P over 3. So here is 4A, and here is 8.
Well, I thought the forces were the other way around.
No, those are reaction forces, right?
Oh, yeah,
Those are the other way.
Oh, yeah, you're right. So this is coming backwards. This is coming backwards. F8. So I can write my equation like negative F8 x minus 0 to the power of 1 plus FB x minus 4A negative x minus 5A 1. So I integrate this and I get.
Wait, how do you know which one is the what minus power?
You mean this power?
Yeah.
The power, yeah. Because it's a forces, so it's a negative 1.
How about if it's a moment? If you have like a moment.
If it's a moment, it's negative 2.
And
Okay,
then,
so
and then
moment
what happens when you get it? Because I saw that there's like some zero. When you get a zero?
Okay, so when I'll just write it. So when it's a moment is negative 2. If
Okay.
it's a force, it's negative 1. If it's a distributed load, okay, it's 0.
Okay.
Yeah, but do you start from which point do you start from?
So the starting point is always here.
Okay, and then the end point. And which one do you subtract usually?
So to use this, if you are going that way, the end point always has to be the end of the power as well.
Okay.
So that's the one that's negative.
What do you mean by negative?
So you could first go. Let's say the first one is 2, and then the other one's 5 distance. Let's say this is 2, and this is 5.
So you just need to write like this, right? Let's say this is 3.
Okay.
The height is 3.
Yeah.
It's equal to 3 x minus 2 to the power of 0. You don't need to include 5 right here because 5 is the end of the bar.
Also, 5 is the end of the bar.
Yeah. So
Oh.
if it's not end of bar, you have to do like you have to add something in.
Okay. I just write this down.
Okay. And when it's a triangular load, then it's positive 1. But if you are not used to this, you have to like go through a textbook. Like,
Okay. Oh, and that's plus 1 right there.
It's triangle.
Yeah.
Okay.
If it's triangular
And
load,
is it always the same thing if it's at the end, you don't include the end?
Yeah.
Okay, cool. Now I got it.
Okay. So now we got this one. We integrate this. It's going to be negative F8 x minus 0 to the power 0 plus FB x minus 4A to the power 0 minus P x minus 5 to the power 0. And integrate one more time. You can get a moment.
Isn't there like a plus C1 and plus C2?
Where is the C1, C2? You mean for the question?
Yeah, because don't we have to solve for C1 and C2?
Oh, you mean for C1 and C2 at here?
Yeah, don't you actually
Okay,
integrate from
so-
from W of x to V of x? Don't you have a plus C1?
Okay, so if you are using let's say, because I'm drawing a free body diagram here, which I include the force at here.
Yeah.
Right? So in that case, you don't need C1 and C2 when you are integrating for Vx and Mx.
Never.
Yeah. If you are including all the forces, you don't need C1 and C2. You don't need to add any constant term.
So the only time you need constants is after when you go from the moment to the slope, it's the slope
Yeah.
to the deflection.
Yeah.
Okay, cool.
Sometimes a professor do add in C1 and C2 at here is because he did not add in those force. So in what I'm doing here is I added every force here, so I don't need to add in a C1 and C2.
Always the case, right?
Yeah.
Okay.
So
I'll just take your word.
okay. And P x minus 5 to the power 1.
So are you driving or you're integrating this down?
I'm just integrating this now. Is it to power negative 1 to 0 and to 1.
But
Okay, and as you can see here, you got two unknown, FA and FB. So what you can do here is by one method is using your method, which is using the moment, and the other method is using V5A is equal to 0 and M5A is equal to 0. This is saying that the shear force at this point and the moment at this point is equal to 0. And by putting these two in, you can put the x to 5A, 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 and you can get the two unknown.
You can find FA and FB.
Yeah, because you got two unknown and you got two equation over there.
Okay, so wait, let me just write that.
And then after that, we just draw after we're done, right? We figure it out. We got the FA and B, right?
Yeah, and after this, you will get the FA and FB, or you can just simply do it in moment and sum of forces.
And then afterwards, after you integrate from there, you get C1 and then C2.
Yeah, if you keep on integrating, that's it. The next step will be E1, EI dy dx equal to, this E is the Young modulus, is given here, EI is constant, EI is constant, is equal to, you keep on integrating and you get.
Isn't it EI dV dx?
Yeah, you can write as, yeah, D, yeah, doesn't matter, I use it Y here. FA x minus A to the power of 2, and now you get divide by 2 plus FB divided by 2 x minus 4A plus, is it? It's a minus F, oh, this is P divided by 2 x minus 5A power of 2. And you integrate one more time, and you can get EI V, which V is a deflection and dV dx is a slope. Integrate here and you get negative FA over 6 x minus A to the power 3 plus FB over 6 x minus 4A to the power 3 and minus P over 6 x to minus 5A to the power 3.
And then you solve for V and for dV
Oh,
dx.
I missed something here. So you got the constant here
Okay.
now. So you got C1x plus C2. So now you got everything here except the constant term, because you solve for FB and P, FA and FB over here there. And now you got two unknown here, which is C1 and C2. So with two unknown, you need two equation, which is the deflection at this pin is going to be 0 because there is something blocking there. So deflection at here is going to be 0. V0 is going to be 0. And V4A is going to be 0 because there is a pin here which is blocking the deflection.
Cool. But that means C1 is 0.
C1, it can be, like if you put in a number, if C1 is 0, then C1 is 0.
But this is where you plug in, what do? You do the...
Yeah, you plug in this one. You plug in V0 is equal to 0 because if you look at the question here, there's a pin here.
Okay.
So the deflection at this point is going to be 0, and the V4A is going to be 0 as well because something is blocking it. So it's the deflection.
So how do you write it? That's fine.
So you V4A is equal to 0. So you got these two equations. Now you just need to put them into that term over there.
Okay.
So I'll put 1 and let's see how it works. So you see EIV is equal to negative FA over 6 x minus A over 3 plus FB x minus 4 over 3 minus P over 6 x minus 5A 3 plus C1x plus C2. So now our x is 0, you put in 0 for it. And this term is going to be 0 because x is 0 right here. So 0 is equal to 0 minus a, which is
Negative, right?
is not going to work this way because in singularity function, this has to be bigger than this.
Oh, okay, so in this case it's 0, right?
Yeah, so this case is 0, 0, 0, 0. So C2 is 0 right here.
Wait, why is it 0 again?
Because if you are using singularity method, the rule 1 is x has to be bigger than a.
Oh, okay.
Because x is 0 in this case, so it's always smaller than a.
Okay.
So this term turned into 0, this
Zero.
term into
So it's
0.
basically one of those algebraic problems for the first one, right? Where you want you to just find because the final answer is just going to look like this v is going to be 0, and then what's our bending? Right after this one, okay, the first one and then the last answer.
Uh-huh.
So our last answer is going to be what, 0 and 0?
Yeah. You mean this part and this part?
Yeah.
C2 0 for that one.
Yeah.
Okay, C2 0. Okay, and then C1.
Then
You
you use
the second
this to solve for C1.
Okay.
So now you put in 4a at here.
Mhm.
It becomes 4a minus a, which is 3a.
Okay.
And 4a minus 4a is 0. And 4a is smaller than 5a. So this term goes to 0.
Okay, so we're just left with F5A.
And you got this C1 times 4a is equal to this term. Is equal to FA divided by 6. There's a negative sign here. 3a to the power of q. So you got this thing and you solve for what is C1, which is in terms of A and P. Here's FA. Yeah.
How did you get the conditions again?
This, okay.
Yeah.
So if you look at the question over here, you see there is one pin here, right?
Mhm.
So deflection here is 0. And you see there is one pin here, so deflection here is 0 as well.
Okay, so you just look at where the pins are?
Yeah,
Okay.
you look at where the pin is. So, any more questions?
No, and then our final answer is going to be
Okay, so let's see. So if after you solve for C1 and C2, you can get the deflection in terms of everything you
And
know
then
here.
you get the slope too.
Yeah, and you can get a slope because you got all those in known like P or A. But what you need to do is like you need to try to figure out where is the maximum in the equation. You get what I mean? Like you got a whole equation with all the nodes in C1 and C2. Now you need to like maybe arrange it and see which point is the maximum. So in dv, the slope is equal to 0 is going to be the maximum point of this. This is like what you did in the shear force and moment before. Like when shear force is equal to 0, the moment is going to be maximum.
Mhm.
Yeah.
How did, in the first part, like the FA term, how did 0 turn to A?
0 turns to A.
no, I think you just wrote it wrong.
Yeah, that's a mistake. Yeah.
Is it supposed to be 0?
Yeah, it's supposed to be 0.
Okay,
That's
I
right.
was just
Yeah,
making
the only
sure.
thing that changes is the powers, right?
Yeah, it's a power and when it turns to be bigger than like 2, when it's integrating to 2, you have to bring the 2 down.
Yeah.
Like what you did.
And regular, yeah, anything.
But not in negative sign. Only in positive sign. Okay. So I just went through the question 1 and sample 1. Okay. But this type of question will be coming out in sample 2 as well. Again. We will try this one. This is in exam 3, but this supposed to be in your previous exam question,
Yeah.
right?
Uh-huh.
Like, this is only asking you for the shear force and bending moment. So by using singularity function, you just need to do till there, and you can get shear force and bending moment.
Wait, what is this one? Is this one we should draw the graphs again?
You mean this one?
Yeah.
Yeah, you need to draw it like that way and keep on doing to get a shear force and bending moment.
Oh, okay.
Yeah, but this is not asking for deflection and the slope. If it's asking for deflection and slope, you have to integrate 2 more times.
So it's omega shear moment, and then we're done. 3 of them, right?
Yeah.
So the first one will be shear force, and the next one will be bending moment.
Yeah.
Okay. Yeah, I remember dealing with those graphs.
So maybe we'll just go through it and if we got time and we'll
Can we go for one of those more circle?
Mohr circle. Yeah, sure. The next one. Yeah, this is the Mohr circle.
That's I have trouble with that.
Okay. This is in exam 3 sample 1. So,
It's okay, this test is Thursday.
Yeah. Dude, I read this Thursday.
I got a mess to study. It's good not to study. Break the best to study like one day of your life and then give yourself 2 days break and it sticks.
You want to try it? We'll try like for about 3 to 5 minutes.
Do you understand what to say?
I think so, kind of.
I think we've had this as well. Hey, do you have to take the final Gabinos class?
Yeah.
Do you have to take the final Gabinos class?
In coming up?
No. No? You got any on the second one?
Yeah.
Nice.
115.
115?
Yeah, because it gave us bonus point.
Nice.
If we did a project, something.
So no final for you, huh?
Yeah.
Man, he's so lucky. I don't know how many remember this one was. Wait, what?
Isn't that the regular formula, right?
Dude, I thought it was like x plus y over 2.
Just,
Why is it 6x?
no, this is stress.
Stress.
Yeah. This one.
I see 2.
We just have to memorize the C and the R, right?
Yeah. And the tension. If I'm not wrong.
I wish we had a cheat sheet. Damn.
But I mean, idealistically, we only have like 5 formulas total. Just keep doing them until it becomes second nature on Thursday.
Oh yeah, I heard about it, but
I didn't know that. I was like, oh shit.
I think we just need this tree equation for this more circle. Do you still remember? We didn't use it,
Yeah, pretty much.
right?
Although when I was doing the homework,
Uh-huh.
especially on the second 2 questions,
Like they got a slope inside a square.
yeah, that confused me. When
Okay.
they like ask you to do something with another angle
Mhm.
and stuff.
Okay, maybe we'll try it later.
Okay.
It's not in the sample.
Yeah,
Yeah.
this one's not
It's-
so bad.
He didn't go through those in class.
Yeah, I don't think not thoroughly at least.
Okay. I think we'll start like going through this question here. So for more circle, it's basically if you have a plane like this, you can turn it to the angle in which like if I turn it to a specific angle like this, and it becomes like this, and I can using sine and cosine and change all the force into just normal stress. Instead, I have shear stress at here. I'm just using a sine and cosine term. And by this is called a principal plane, which the stress is biggest and smallest at here. If I turn it again at 45 degree from this principal plane, I'll get one which is the maximum shear plane over here.
Okay.
So the maximum shear is when the maximum shear, if you can see here, the principal plane here has maximum normal stress but no shear stress. But in the maximum shear plane, you have shear stress and normal stress. This is the case, like. And what a Moore circle do is he draw a circle which includes all the plane in the circle here.
Okay.
So the first thing you'll need to do in this question is to find out where the center of the circle is. by using this equation.
Okay.
So by using, to find the center, we'll just C equal to delta x, which is sigma x, which is equal to 1000 plus 6 plus y, but this is in negative direction. So it's minus 600 and divide by 2.
What about the 150?
150 is shear force. So this is, you see this in
That's
both
stress,
is
yeah, yeah.
normal stress,
Yeah, my
and this
question
is
is, how do
shear
you know,
force.
how do you know if the shear force is negative or positive?
Okay, so this is a negative one. Like if this is a plane and you got a point here, so this thing is turning anti-clockwise, right?
Oh yeah, so then that means it's positive, right?
It's negative
If
here.
if it goes counterclockwise?
Oh, I'm sorry. This is counterclockwise, right?
Yeah.
So this is a negative. If it's clockwise here,
It's positive?
yeah.
So it's like, it's inverse, like in physics, because counterclockwise is positive in physics and clockwise is negative.
I think so, but this is how it goes.
Alright, so this is how it works in here, right?
Uh,
Okay.
Okay, so as you can see, if you are doing on this plane, you put a point at here,
Mhm.
and this thing is turning anti-clockwise, so it's a negative one. Okay. Okay, so now we just put in everything here. 1000 minus 600 is 400 divided by 2 is 200. So the center here is going to be 200. And we get the radius. The radius is just the square root of, this is 1000 minus 600, so it's 1600 divided by 2 squared plus,
Negative 150.
yeah, negative 150 squared. So by getting this, you'll get a radius over here.
I got a good question though. So we just use this right one, right? On the playlist, we just use this right one. We never.
You mean this one?
Yeah.
Yeah, you can use this and this, but I usually just use this.
Just use this one, right?
Yeah.
Okay.
Okay, so anyone calculate this one?
320.
320. So you got a radius is 320. So 200 minus 320 here is negative 120 because it's a radius, right?
Okay.
And here is 200 plus 320, which is
320, okay.
520. Okay, I'll erase this. Okay, so now the next step is to find, I'll find this plane in this Mohr circle. So this, the y-axis is always shear, and the x-axis is always normal stress. So at this,
But wait, don't we start at 0? Isn't the plane at 0, not at 200?
yeah,
It's 200 on the x-axis. Right?
yeah, 200 on the x-axis, and 0 on the y-axis here.
Alright.
Okay. So the next thing we need to do is we find this plane over here. So the normal stress is 1000, which means in x we need to find 1000. Is it? Did I did something wrong here?
That's not what I got from the radius.
What do you get from here?
Like 800.
800. I think 800 should be right because
Yeah, that makes more sense.
8 plus 2 is 1,000.
let's
We're
say
at 800.
800. You need to check it. This is
So R is 82 squared?
yeah, it should be more. This
Oh.
is 1600 square divided by 2 plus 150 square. Let's say it's 800. Okay, so
Minus
this will be negative 600 at here and 1000 at here.
1,000. Okay, that makes sense.
Okay,
Is
so
that your approximation?
what?
Is that, wait, well, what's the radius?
The radius is
It's like 813.
oh 813.
Yeah,
Okay.
813.9.
813.
813, yeah.
0.9. So this will be 200 negative 613.9, and here will be 1. Here will be 1013.9. So you are looking for when x is equal to 1000, so which is very near to here. What you need to do is just draw a straight line down here, because as you can see, the shear stress here is negative, right? So you are going down, which at this point the shear stress is negative.
Okay.
And you draw a horizontal line over here, and this is your focus. Focus. Okay, so finding the focus is important because you need to draw all the line from the focus. So now he is asking for obtain the principal stress, which is a maximum and minimum stress.
Hold up, so my question is, if it was positive, then you would go up?
Yeah.
And then you would draw a line to the focus?
Yeah, if it's positive and you draw it like here and you go in here. Okay. So you got a focus here, right?
Yeah.
So now you have to look for the maximum, normal stress, and minimum, which is at this point and this point. Because the x-axis is always a normal stress, so at this point is a maximum, and this point is a minimum. So you just draw from this line to here, and draw from this line to here. So you get two plane over here, which here is just negative 600. How do I get this is based on this point. This point, the x is negative 600 and 13.9, and the y is 0. So y is a shear stress. So I got no shear stress at this point, right?
And so you just go straight up from that point when you get to the focus?
Uh-huh. Yeah, and this point, we got 1013.9. So if I draw it like this, it will look like this, 1013.9. So there is no shear force as well, because at this point, the y is 0. Okay, everyone got here? Okay, then the next step will be the maximum shear stress. The maximum shear stress is at this point and this point, the highest point and the lowest point on y-axis. So I draw it from here and draw it from here. So at here,
Wait, what we found before was the principal stress.
yeah, which is a maximum normal stress and a minimum normal stress. So you keep on drawing at here, you get the maximum shear and minimum shear, which at here the shear is at y is negative 613.9. No, I'm sorry, negative 813.9.
Okay.
Because it's a radius over here, right?
Uh-huh.
So the y-axis at here.
So they're both going to be the same.
Yeah.
It's negative and positive, right?
Yeah, because it's a radius. So if you write this in xy, you get like the x is 200 and the y is negative 613.9. So we just put the 200 to the normal stress and a negative 600.9 to the shear stress.
Got it.
You just need to change the x and y coordinate into normal stress and shear stress.
Got it.
So this point, the x coordinate will be 200 and the y coordinate will be a positive 613.9. So that's it for this question.
I should put like 3 of those on there.
Everyone got this one?
Yep.
You okay?
It's so different than the one from the book.
Yeah, he mentioned that not to use the method in the book.
Yeah,
He wanted to be this. Yeah.
Oh, because I used the other one.
So when we were doing, before we did the second one to get the maximum, those are the principles. And then when you just for the focus, you just wanted to get to the y.
No, use
Yeah.
this.
That's all you did. You didn't want to go to the end of the circle. All you wanted to do was hit the y. I mean the x-axis.
Yeah.
Okay, that's all you do is you try to hit the x-axis.
If you hit this 2 point, it's going to be the principal plane. If you hit this 2 point, it's going to be the maximum shear plane.
Okay.
Yeah.
I thought the radius was 813.
800. Oh, I'm sorry. Yeah. Here is 830. Is a radius of here.
So when I get to that focus, to find the principles, I just have to hit the x-axis, right?
Yeah.
Where is the 2 theta?
Yeah.
Like
Now we will
where-
need to add in the 2 data here now because. Oh, this is.
And when you're drawing the Moore circle, like, does he want you to draw that in there too, where the 2 theta is?
Yeah, he will want you to draw where the 2 data. That's it's easy. You just need to calculate this. Let's say I put in a number here. I would say not to use the method in textbook because he mentioned in class that he didn't want the method in textbook. He wanted to do it this way.
Okay.
Did he really say that?
Yeah, he said it in the class, and he told me not to use the method in textbook to teach you guys. So be tangent inverse because he is saying using the method of focus, which is not the same way of the textbook. tangent inverse, if you put in everything here, so
Yeah.
tangent inverse
This is
minus
what
one.
I don't know. I hope so. Wait, I just have one more question. How did you get the arrows for the shear stress? How did you get the arrows?
Whether it's positive or negative.
Yeah. No, like for in the graph, you
You
right
mean
there. Yeah.
this one?
Yeah.
So if you can see, this is a negative shear stress, right?
Yeah.
So if you look at this, this is a wall, and you put a point here. So to get a negative one, you have to go anti-clockwise, which is here.
So you go anti-clockwise, and then if you want positive, you go clockwise.
Yeah.
Okay. Cool.
Does it matter which way you draw the wall? Like if you make it on the other side?
You usually draw it in the inner side of
Okay.
it. And if you get this, let's say, I'm just assuming this is
But
a,
doesn't that mean that on the other side the arrow has to be pointing down because it's going clockwise because it's positive there?
you mean like the up
Yeah,
one, this
yeah.
one, so now you put a point here, you have to point clockwise. So
Okay. Wait, but you didn't do that. You drew that.
Yeah, I didn't draw the arrow.
we have to draw this when we draw the Morse circle.
Yeah, you have to include everything, including this data.
Okay.
So
But with these circles too, like with these shears and the arrows, right? We have to draw this too.
yeah, you have to draw that. So now let's say I got the data here. I'm just assuming the angle is this. I didn't calculate this. So where is the data going to be? The two data is going to be at the focus. This is the focus line, right?
Mm-hmm.
And to the principal plane, which is this one here. You can see this is a principal plane over here. So here is two theta. If you remember what I said just now, like if you move this to a theta, you get a principal plane. If you move a theta and you can get a principal plane stress, right?
Mm-hmm.
And you move theta here is always going to be two theta here,
Okay.
which is the angle here is going to be twice of the angle here. If you remember this, I say just now that if you turn a 45 degree more, you can get the maximum shear. Right.
And then 45 degrees more is this maximum shear now. Okay.
Okay, so the 45 degree here is going to be 90 degree here. So this and this is going to be 90 degree.
Got it.
Is it always that principal plane that you measure it from?
Yeah.
Okay.
So
I was like, when I was doing the homework, I was getting confused because like I get it when the focus is like down here, but when it's like over here or over here, I just get kind of confused as to where.
So the angle is always to be the focus plane to the principal plane.
Okay.
Yeah. So like what happens if our focus was say it was up and then in the left corner, everything else is just pushed back around, right?
Yeah. If it's like this.
Yeah. So we do the same thing except we go to the principles at.
Yeah, everything is the same. It's just like, and you have to like draw it this way and this way.
Wait, so 2 theta is 30 degrees, right?
No,
Yeah,
we can't assume that just
Yeah,
so
we
we
just
can show
assume
some
that 2
example.
theta is 30 degrees.
Okay.
And where do you gotta draw it?
So here is going to be theta, which is 15 degrees. Something like that.
Yeah.
2 thetas. Yeah.
And when you draw the final diagram with the 2 rectangles, do you use theta or 2 theta?
In the diagram, it's always going to be theta, and in Morse circle, it's going to be twice the angle from the diagram.
Cool.
But here, he doesn't require you to draw all this. You just need to draw this and.
So we put that 30 when we find out our theta, right? Then we just put it right there. Principal to the, from the focus line, right? To
Yeah.
the principal line is 30 degrees if that's what we calculate for our angle.
Uh-huh.
And then 45 to that makes 90, or whatever, gives us that maximum shear, which is that
Yeah.
line up top. Okay.
But the main thing is to include this
Okay.
limiter here. Because it's always 90 degrees. You got a question on your class?
Yeah, also, yeah. Why? Oh, never mind. Now I get it. Okay. I got confused about the 6.
If everything is alright, we'll try the more circle question. Like in sample 2, this one. So it's just the same process, except this part. We'll talk about this part later, the last part. You done this one? you using the method in textbook or
Textbook.
the textbook?
Yeah, they know nothing about focus, which is why.
He mentioned that not to use the method in the textbook in class. Yeah, I'm not sure if you heard that. Because if he mentioned it, using the method of focus means that you have to use the method to use in class.
Yeah, that's why. Yeah.
I write the equation here.
I get 6.
You got 34.
Mm-hmm.
My 0.83. Also, I have a question. When you're drawing that means this has to be this is 1.83. The axis is around here, right?
Yeah.
Or you draw the axis here.
It doesn't matter, you can just draw it up here. Because he doesn't care where is the blue axis.
Okay. Okay. Thank you. It's the
Oh, my school? Yeah, somewhere here.
So this coordinate would be
six 5.83, right?
Is it?
This would be 6 5.83.
Yeah.
This would be 6 minus 5.3. So if you draw this,
Or
this would be negative. So it'd be like this. This would be like positive.
And he wrote just positive 3. Yeah. Yeah, when I was doing it in the book, I think that
this would be
the
x
opposite. No, that was from here. That was before. Oh, here you wrote it. You wrote that counter, or that clockwise is positive, counterclockwise is negative.
So this will be.
Yeah.
Yeah,
So that's right.
Yeah, that's right.
Yeah, you're
Okay.
right. Okay.
Oh, maybe we should do it together now. Okay, so let's start for this. Okay, so now the first thing is to calculate the center, which is equal to 9 plus 3 divided by 2, which is 6. 3? Yeah, I'm sorry, 6. And radius is equal to, using this equation, 9 minus 3 squared divided by 2 plus, here is negative 4 squared, and you can get,
It's 5.
it's 5, okay,
No, it's like 5.83.
5.8.
I got,
6 squared 36 divided by 2 is,
5.83. It's radical 34.
yeah,
Radical 34 is 5.83.
okay. So the 2 is not inside the square. Okay, and you get this, then you can start drawing a more circle. Okay, so let's say I put my center 6 at here. Here is 6 minus 5.83, which is equal to 0.12.
1.7.
1.17? Okay.
1.83.
6 minus 5.8. Okay, so here is,
Do you have 8.9 or 8.3?
is it 8.3 or 8.9?
8.9.
8.9?
Oh no, 8.3.
8.3, okay. So here's 8.3. So now you can draw your circle. Like this. Okay, so the next step is to find this plane. So this is a positive 9, which is at here. And this is a negative 4. So you're going down and draw it this way. Did you make a calculation?
Wait a minute, hold up.
Yeah.
So when you're doing that method of focus,
Mhm.
what are you looking at exactly?
Always the right side, right?
You're looking for the focus.
Yeah, but the plane, we always use this plane, the one on the right side.
Yeah, we always use this. You can use this
Yeah, I
as well.
get that, it's, that the shear force is negative,
Uh-huh.
but you looked at the plane stress too?
Yeah, the plane stress, you mean this one?
Yeah, you have to look at that one too?
Yeah, because this is going to be in your x-axis.
Okay, hold up, so that means if it's negative, you have to go on the other side?
Yeah, if it's a negative 9, then it will be here. But
And you're looking at the x plane stress, not the y?
the x-axis is a plane stress and the y-axis is a shear stress.
Okay, cool.
So at this point will be 9 minus 4. But you don't need to calculate for the minus 4.
Yeah,
Because
no,
it's
I got it now.
I think that the 2 is supposed to be in the square.
In the square?
Mhm.
Okay.
What?
That's how I've been doing it, and that's what I think we wrote down last.
Oh, okay. Oh, yeah, you're right.
What's the square? The square in the square. Two squares.
The 2 is in this. The 2 is in the square, so
So you have to first do.
yeah, this part is square. So this will be 5, but we'll just continue with this 5.83. That's
Okay, yeah, it's fine.
okay. So now he's asking for obtain a principal stress. So where is the principal stress?
At the x.
At the x-axis. Okay. So just this point and this point. Just draw from the focus up to this point and draw from the focus up to this point. So from here you need to draw the stress.
You have to draw any arrows there.
Yeah, you have to draw the arrow. So what would be the arrow here?
Because they're both positive, then you're going up.
Mm-hmm.
And one is going to be 0.17, the other one's going to be 1.83.
Yeah, 0.17, and here is 11.83.
Cool.
So this number comes from the x-axis.
Okay.
Okay, so he's not asking you for the shear, maximum shear, so you don't need to draw for this too. So it's fine. And now, if you look at the question, he's asking you, obtain the stress on a plane that is clockwise 30 degrees from the plane of maximum principal stress. So this is the maximum principal stress plane, right? And he's asking you for a clockwise 30 degree. So you need to turn a 30 degree from here, turn a 60 degree. Because
Wait, so if it says 30 degrees from the plane, that means 60 degrees.
yeah, 30
Circle.
degree, if you say that the 30 degree is here,
Yeah.
then here will be 60 degree. But if you are not sure that the 30 degree is for, if he's saying for this or for a more circle, you can just assume.
So now we're assuming that theta equals 30 degrees.
Yeah, we are saying theta is 30 degree.
Okay.
Not theta is 30 degree. Theta is this one, which is this plane to the principal plane. But he's asking you, we'll call this theta 2.
Okay.
Theta 2 is 30 degree, and 2 theta 2 would be 60 degree. So
Okay.
you're turning from this, turning a theta 2,
60 degrees.
60 degree, maybe it's here, 60 degree,
Okay.
and you get this point.
So is that always going to be the plane of maximum principal stress?
Yeah, because you are going through at this point.
Okay.
Because at this point, the x-axis is the maximum. So this is always the maximum principal stress plane.
So, what did you draw?
First, you have to calculate for this 2 theta. First.
Yeah.
Let's say the 2 theta, I'm using this equation, I get is 40 degree, right? I'm just assuming it's 40 degree. So this will be 40 degree. So from here, you turn at 60 degree, which is 20 degree below the horizontal line.
Okay.
But then how do you calculate the maximum for that?
With what maximum?
Because they said also obtain the stresses on the plane that is
Yeah,
cloud.
okay, so what happens after this? That's
Yeah,
what we draw.
after this, what do you do after this, after you draw it?
So after you draw this, you just need to find out what is the x point and y point for this. Because it's obtain the stress, which is that can be a shear stress or normal stress.
Okay.
You need to figure out what is the x and y here.
And how do you find that out? That's my question.
That's the center of the ring.
Yeah, so it's if you draw it like because you will know this degree over here. So you have this, and you can use
60 degrees, right?
it's not 60 degree because 60 degree is from here.
Oh, okay.
So this will be 60 degree minus 2 theta. This is 60 degree minus 2 theta over here. And by looking for, you have to look for the distance here. You know here is going to be 4, right? So here is going to be 5 minus 4, which is 1. You can look for the distance at this here. If I draw it again, let's say, if I draw my circle here, this is the focus line, and now you are looking for this triangle, right? But
Oh yeah, it's 4, of course.
you got this, you got the distance from here to here, which is 4.
Which is 4.
So of course you can get the distance here, which is radius minus 4.
Got it.
And
Yeah.
with this, you should be able to get the points over there.
And that's all we need to do and we're done.
Yeah, because you get the 2 points at here. Let's say your x is equal to 2, your y is equal to -1. Your normal stress is going to be 2. Your shear stress is going to be -1. Because x is always normal stress, y is always shear stress in Moore circle.
Wait, so that little break over
just,
there,
you know, just saying.
that's the radius minus 4?
You mean here?
Yeah.
Yeah.
Yeah, because
Four
here
is
is
your
4.
And then afterwards, you just got to find the hypotenuse, and that's our.
Yeah, so in that case, you already have like that side, so you can do
Yeah,
sine, cosine, and all that.
maths.
Okay.
Maths part.
So you gotta know your treatment.
Yeah, I know.
So you just have to find the point that it.
Yeah, you need
Find
to
the point.
find a point. Find this point that it crosses the circle, which is this point.
Which is easy. You just find the x and y, and that's your.
Yeah, currently I'm not sure what way would be easier, but the main thing you need to find is this point.
And then after
And
you
you have
find
this angle.
after you find your x and your y,
So you do.
which one is your
X is
X is the normal
normal
stress.
stress.
Yes, and Y is shear.
Y is shear.
So the X component is shear. Y is
Okay.
I mean Y is shear. X is shear.
That's the Morseable. Just go through like this is in the previous exam. I don't think you count this again. But
Is he actually gonna put like, oh yeah, like something like that on?
yeah, I think so because he go through this in the last class. if I'm
Yeah,
not
I
wrong.
don't really understand.
Yeah, like
I have no plug for this.
this is just combining all the stress together. Like if you look at this question, he's saying that this is a flag maybe.
Yeah.
This is a signboard. So there is wind coming here. So the wind is going to the board. Right. So if you look at here, it's asking you for the maximum shear stress on here. So you have to think now.
Whoa, hold on. So you're trying to find the maximum shear stress of that beam?
Yeah.
Okay.
So because it says the maximum shear stress in the post is not to exceed 5,000 psi. So the first thing you need to like kind of visualize what's going on here. So the wind is coming here. So the force is in this direction as well.
So it's pushing on.
Yeah. So it's like pushing here. So if you look at here, you know that because they will create a shear stress at here, any point of the bar. Let's say.
Is there two shear stresses?
Yeah, there will be two shear stress in this question. So this
An X
is
and a Y, right?
no. This is a flat post. So the wind is coming here.
Yeah.
So if you cut it like this, you'll see that there will be force. This is a cross section.
Okay.
So there will be shear stress that
Yeah.
that
What
was.
about at that flagpole right there, where where it starts going vertical again?
Hold up. Let me first finish this.
Okay. So there will be shear stress at here, cutting here, right?
Mhm.
Which is parallel to this plate, and you have to because of here and the distance here, so there will be a moment. So if you just look at because this is and because of this distance, there will be a moment which creating at the post. It's a torsion. It's a torsion to the post itself. So, but I'm not sure which chapter is it, but
Yeah, but do you think when you do the torsion equation, do you use its T equals tau C over J?
yeah, TC over J. So the T will be the moment done by this. C will be the radius of this one, the post. J is the J of the post. So
Wait, J would be
pi over Q R, right?
So it looks familiar.
Yeah.
Would there be two C's though?
What?
Would there be two shear stresses?
Yeah, the first shear stress is just done by simply of the force itself.
One, I'm just saying because there's two different points, one on the left side of the post and one on the right side.
What I'll do is I'll just like focusing all the force and put a point in the middle.
Okay.
Because it's not like saying which point is the force. It's saying if you look at the question, it's saying like it's 20 pound per square foot. So it's like you get the average force for this whole signboard.
And then if we get that one, what's the second shear?
The first shear is like the cutting one.
Okay.
The second shear is because of the torsion.
And then that occurs right where? Where does it occur on the diagram? The second shear.
The second shear it occurs all the way on the, as long as it's in
the shear you use with the torque.
Because I'm just wondering, there's not going to be nothing where it's like connected to this pole. Nothing there, right?
Where?
Because I'm just wondering in these problems, yeah. Because then we have a shear there because it's pushing on it this way.
Yeah.
And then you've got the torsion because it's twisting, right?
Yeah.
And then that's it.
Yeah, that's it for this question.
Okay.
But there will be
Can you do this one?
this one. Like if I do it, I would like the first step I just tell equal to f over a, which the f here is 20 times because it's per square foot, so it's 4 times 3. This is the area and this is the force, and the a here is the pi r squared of the post
Okay, the shear.
because the cutting area is here.
Do they give us R?
R?
No, you're trying to find R.
Oh,
Yeah, you're trying to find r.
All right.
So if you lift it r here, and tau, this is tau 1, tau 2, will be Tc over J, where T is F times
the distance here to here, which is 2, and the F is this, C is a R, and J is pi over 2 R power 4. So now you need to say the maximum shear stress is not to exceed 5,000. So tau 1 plus tau 2 has to be smaller or equal to 5,000 here. And I'll put equal together.
So tau 1 plus tau 2?
Yeah.
Okay.
Because if you draw it on, you cut it here and you look at, if this is
and,
sample,
and then you solve for R.
yeah,
Okay.
the shear stress is going to be look like this because of the force, and 1 is because of the torsion. So they can be the same way or different way. Yeah, but we'll use the same way to get the maximum shear.
You go back to that.
How do you make sure that it's gonna be less than 5,000?
You just tau 1 plus tau 2, which is the maximum shear here, is going to be equal to 5,000 to find the maximum R.
Okay, so you set it equal to
Just
5,000.
fx is just force 2, right? We don't know that fx yet, right?
No, it's F times 2.
Oh, f times 2.
Yeah, the F is 20 times 4 times 3.
Why is it times 2?
Times 2 is because of this distance. T is the torsion, which is the moment.
Okay.
F times 2 here.
Wait, and then that 2, that distance of 2, how did you find that again?
It's the middle of the thing.
Yeah,
Also, it's the
I'm
middle.
just assuming that the force is in the middle at here.
Oh, so you're, okay.
And this is just one of the sample, but can be anything.
Okay, and then we just what's it called substitute to figure out the go
Yeah,
back. Right?
you figure out it's just shear force, normal stress, and torsion moment.
And then in this case, we're just gonna do T1 plus T2 is 5,000.
Yeah,
And
get
then
an R.
Start playing everything off to get rid of the R's.
This makes you to study all this stuff. Like,
Is this in a chapter of the book?
the last two, just we covered it just yesterday.
Yeah.
yeah,
Oh,
you
today.
just go through like 20 minutes. I'm
She's
not
Yeah,
just like,
really
okay.
fast.
Yeah, so this is chapter 13 or 14?
sure. I'm not sure which chapter it is.
I don't know.
But he didn't give homework on this, and
So, and then that's all we're gonna do.
yeah,
And then what's the fourth problem?
the fourth. There's only 3 problems here.
On each, and but he said he's gonna give us 4.
Yeah,
Yeah.
So you're going to give us one on singularity, Moore circle, and this.
And then he's gonna give us another one probably on Moore circle.
No. Or pressure vessels.
Yeah, what
Pressure
are pressure
vessels.
vessels?
I've never seen this before.
no one knows.
I think just memorize the equation.
Yeah, pressure vessel. You just need to memorize the equation. And look at an example in the textbook. This is
What chapter is that?
pressure vessel is.
Okay, I think it's good, right?
I think it'll be fine.
Yeah, actually. Does he curve the final, or what does he do?
I'm not sure
I got
about this. Because he didn't mention anything of the final. Like, pressure vessel.
There's exactly something kind of recording.
Pressure vessel is in chapter 14.
Okay.
And there is more circle in the pressure vessel, but I don't think you will need it. You just need to like see.
Yeah, his
what-
questions aren't that hard.
He talks about
What
Hooke's
these
law.
do is because-
Yeah, I don't know
Oh,
about it.
no,
Yeah,
that- okay.
because he didn't give us this on the previous final.
Does he have any problems like that on these
On no,
samples? Okay.
yeah,
Well,
I don't know about that.
not
first one,
really
so-
worried about it. but-
No, I was just.
Ready made and flip it over.
Did you go over the focus to that?
Yeah, sure. If you ask
Oh.
me that,
I didn't think of it that way. Yeah.
oh, we'll just take this question. Like, let's see. If we take this question.
I didn't do it, but that seems pretty easy.
Yeah. So, you mean you use method?
Yeah, especially for homework.
It might be similar, but it will want you to include the focus.
Yeah.
So you know how to find for the center and radius?
Yes, there is a center. It's the same equation, right?
Yeah. So
No,
it's like-
you have to sign this?
can you help me with the sign on the paper?
Oh, yeah.
You got a sensor here and you find a radius here. So say this is the wall. And you go
The right.
so you need to find
Hey,
this
so
plane
I'll,
you do more
I'll just text you.
Let's say this is one.
Well, I bet you email you guys. Finish like copies of what.
So you need to find for the tree which is a normal stress. No, tree is a normal stress here. And you have to look for point 3 which is here. Because the x-axis is always normal stress.
Yeah, it's just, so is it always?
Yeah,
this
dude,
plane?
Yeah, you can take this way or this way, but it's going to be like 180 degrees. So
Just because, what if this is
yeah,
here?
yeah.
Like this
Okay, let's, if we take this, change this. Change it to like here. Which is one. You write it as 1 by your negative 1 is here.
Well, I'm not thinking so.
Go it down. This will be this plate. And you just need to draw the focus. Okay, thank you. So you just draw it downwards because this is a negative 3.
And it's always the x-axis plane that we're looking at?
Yeah, because it's much easier to look at. If you're looking at. If you're looking
saying
for
like, we're not taking ever this.
Oh,
it's always this one.
yeah, we're always taking this.
Okay.
You just take this one and we'll find this.
You go down and then move to the opposite side.
Yeah.
Okay.
And this plane is just drawing from the focus which here. And this is the plane. This plane is going to be negative 1. Yeah.
Or
Yeah. Because you look at here, the point. This point is going to be negative 1 and 3.
yeah, but I thought the focus point was here.
The focus point is you need to find a focus point, but this point is this plane. The focus point is you're drawing all the plane from the focus point.
Okay, so you have to find a point?
You don't need to find a point, you just need to draw it out. But
Okay, so here it'd be 1 and negative.
Yeah.
Or 1 and 3.
should be negative 3. Right?
Yeah, so here it'd be 1 and negative. That's just for the point.
Yeah. But if you're drawing this plane, it will be at here.
Okay. So here, how would you ever have to draw this plane, focus plane?
You can do that.
How would you do it?
Like, this is not a real question, but
I don't know.
answer. If it's a real question, it should be the 180 degree from here, which is around here. I'm not sure, but if you want to draw this, let's say, I'm giving
Would you
it
have to? Did they usually draw
If you want us to draw for this, and you want us to draw for this, yeah, you ask you for the principal, and sure, maybe a degree from the principal or sure.
Okay.
Yeah,
So he would do, so this would be principal 1.
yeah,
Principal 2.
yeah.
This would be max shear.
Yeah, max, this should be minimum shear and max. It's just a sign
Well, they're
difference.
the same.
They are the same because this is a radius, the y is a radius.
Yeah, no, they're the same magnitude.
Yeah.
They're different clockwise and counterclockwise.
Yeah,
Yeah. So how would you?
so if you draw it like here, let's say this is 1 and negative 4. So 1 is the positive one, so it's upwards. And negative 4 is, you draw a point here. Negative means you have to go anti-clockwise. Yeah, look at, you draw the point inside the wall, and then turn it, I'm sorry, this is anti-clockwise. Yeah, this is anti-clockwise.
Yeah, because I remember in the book you actually had to like, there were different steps you had to take, and then there was a point where you had to draw the
Yeah,
new
it's like this, right?
Yeah, there was one that you could sometimes do a wedge
Yeah,
where he was the principal and you was the
so it's the same thing here, like, because more circle is just putting everything in the circle.
yeah.
So if you,
Would you ever have to draw this though on the test? That's what we did on homework.
you did it in your homework?
Like I don't know. Do you have a book?
Like in the homework, it's something like this, right?
It's something.
Here, this.
It's like this. They.
He wants you to do it.
I don't know if he wants us to do it, but he always had the answers of. I mean, the book always had this answer.
Yeah,
Or
this
you
is
can-
is included in the Morse code.
Yeah, it is. But like, how would you do it with point of focus?
Like if you're drawing, okay, let's say this is a box, and you go for an angle here, and you get the maximum normal shape, right? This is what is in the textbook. If you go for a data and you get the principal stress, which is here, which you got no shear stress. So in Morse code is basically just this and these two plane
Are the
you
principal.
combine and you get in this one.
But what about the max?
The maximum shear is just this and this. These two plane
Okay.
you combine and you get the maximum shear. All the number.
Why is it a greater angle?
As you can see here to here is actually a 90 degree.
So
in
always
here,
90 degree?
Yeah, because at here is a 45 degree, so at here is always a 90 degree.
Really?
Yeah, it might look like that. It's a 90 degree if you look at. So this is a 2 theta.
Yeah, I understand how the angles work.
Yeah, it doesn't look like a 90 degree. I agree.
No. See, that's why it's hard to believe that.
Yeah, it really doesn't look like a 90 degree.
I mean, I guess.
Yeah.
From the point of, so always from the point of focus. Wait, would this be the 90 degree or this is the 90?
The 90 degrees between the principal plane to the maximum shear plane because it's 45 degree here, so it's a 90 degree.
Okay,
But-
so it's always from the principal one to the maximum.
Maybe. I guess. I made a mistake. 90 degrees here. The principal one to the minimum, and if you look at this.
Or is it the principal one and the principal two?
No. Principal one and principal two is 90 degree, but principal one and shear is also 90 degree.
Oh yeah. So you'd be 180.
Yeah.
So just lie there.
I guess this to. Where is it? He never asked for like to draw the 90 degree the body.
Yeah.
I mean in this, but it's 90 degree for the one circle. It definitely doesn't look like a 90 degree.
Yeah. Okay. So principal one, principal two. You wouldn't have to draw shears here. Here you would have to draw shears, right?
Mm-hmm.
Then this would be. Oh wait, this is the focus, right?
Yeah.
So.
Oh, this is a focus. This is a focus. It's supposed to be a line.
This I understand would be 90.
Yeah.
This would be 45.
Maybe you're right. 45 is in the 45 is in the plane diagram, so it's going to be 98 here. If you look at here, the textbook, like if this is a 35 degree, and here it goes to a 70 degree.
Yeah.
So if you look at here, you say that the maximum, the principal plane and the maximum shear is 45 degree. 20.3 plus 24.7 is 45.
Is it always?
Yeah, it's
Yeah, right.
it's going to be so this is going to be a 90 degree.
In the focus. Okay. And then
But you don't need to draw the 90.
yeah, you don't have to draw the then if it asks, what was the question? It asks from the maximum.
Yeah, which is this plane. And he wants a
Or
60
is it this
degree.
one?
No, yeah, should be this one.
So be this way?
He asking for clockwise, but this is not an original question.
Yeah,
Yeah, so from this is the maximum plane.
yeah.
So you go for, depends on the question, clockwise or anti-clockwise.
Okay, so focus, you always just look at this one,
Yeah,
go down or up, depending on the shear.
yeah.
Here it turns it counterclockwise, so that's how you go down.
Mm-hmm.
Okay. Would you have to draw that though? Or would he just want the more
If he
circles?
just saying about more circle, you just need to draw the circle.
How would you draw this diagram?
This is simple because this is like, you got a theta using a tangent to theta equation. And you got the theta, you just need
Where's
to draw
the theta though?
The theta is just, you draw a horizontal line. This is the theta. Between this plane to the maximum, the principal plane. Theta is the degree.
Between the maximum and the principal?
No, it's between this plane to the principal plane, which is here. This plane, the line is here. And then
What's this plane? Is this the x?
This is just for the original cube.
Okay.
And if we draw it like, the angle in between the original to the principal is theta.
Yeah, so we're on the,
So here the original is this one,
yeah.
and the maximum is this one. So this one here. This
You
one
always
is
take
theta.
the maximum?
Yeah. Because this is yeah, we always take the maximum here. Like this is the minimum. Maximum principal plane. Because it depends on where this is. If you calculate your 2 theta, let's say your 2 theta is equal to 36, you know that it won't be this to the maximum.
Yeah.
It will be the minimum.
Minimum what?
Like,
Oh, that would be the, okay.
because this 2 plane is equal to this whole thing.
So 36,
Let's say 2 theta is 36.
so it would be 18, this would be 18.
Yeah.
And this would be, the one on this way would be this one.
Yeah. So if you know that if you calculate 2 theta is equal to 160, and you know that this angle is going to be bigger than 90,
So the method of focus is different than the method used in the book, but they both have the same answers.
Yeah, definitely they have the same
It's
answer.
just way harder. I don't know why he wants us to. Okay. Do you know? I mean, do you have the actual answers or?
Like what?